How many ordered pairs of integers mn satisfy the square root of n squared minus 49 is m? The first thing I will do is square both sides, and that will get rid of the radical, and then we'll make it like that. And then I'll put everything on one side, so it'll be n squared minus m squared is 49, like that. And then we'll factor. So this factors into n minus m, and n plus m is 49. Now, 49, obviously, I would like to factor that, but there's several. There's 7 times 7. There's also 49 times 1. There's also negative 7 times negative 7. That would also work. And, of course, the negative 49 times negative 1 scenario. And each of these will give solutions. So I'm anticipating there's going to be 4. So, but I have to prove that. That's what I think. So here we go. So the first one, n minus m is equal to 7, n plus m is equal to 7. So then you add both equations, you get 2n equal to 14, n is 7, and therefore m would be 0 when you substitute back in. So this would give the ordered pair 0, 7 for n, for mn. Sorry, m goes first, and then n. mn is 0, 7. And in a very similar way, you're going to go through, so we went through this scenario, so we're going to go through the same thing for this guy and then the other two. So n minus m is minus 7, n plus m, again, minus 7. Again, 2n would be minus 14, n would be minus 7, m is 0. So this one gives me 0 minus 7. Okay, we got a couple more. N minus m, moving on to this one, is 49. Sorry, wait. I don't think it'll be 49. N minus m would probably be less, right? Yeah, n minus m probably is going to be less. Does it say anything about positive? Well, let me just go with my gut instinct that I think it's going to be less. So if we add them, 2n would be 50, n is 25, and therefore m, when we substitute it back in, would be 24. So that means this is 24, 25. And then the final one, n minus m would be less of the two numbers, these two guys, and then n plus m would be negative 1. 2n is going to be minus 50, and therefore will be minus 25, and then m would be 24. Yeah, so this is 24 minus 25. So there we go. Like I had originally predicted, the answer is 4. Zelda played the Adventures of Math game on August 1st and scored 1,700 points. She continued to play daily over the next 5 days. The bar chart below shows the daily change in her score compared to the day before. What was Zelda's average score in points over the 6 days? So the first day, plus 80 from this number. So 80 plus 1,700. Wait, hold on. Let me backtrack here. On August 1st is 1,700. Yeah. And then the next 5 days. So then they want the average. Oh, okay. So we have to include that 1,700. Okay, I got it. So 1,700 is sort of, this is, I guess, the August 1st. And then we kind of go to the next 5 days. Okay, plus 80. So that means 1,700 plus 80. So on this day, it would be 1,780. And then 1,780 minus 90 would be 1,690, correct? Yeah. And then 1,690 minus 10 would be 1,680. And then 1,680 plus 60 is 1,740. And then minus 40 brings it down to 1,700. Now we have to take these numbers, 1,700, 1,780, 1,690, 1,680, 1,740, and 1,700. Add them up and divide by 6 to get the average. And when you do, you will get 10290 over 6, and that, I believe, is 1715. So therefore, the answer here is E. Two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. Consider these four transformations of the coordinate plane. Translation 2 units to the right, 90-degree rotation counterclockwise about the origin, a reflection across the x-axis, a dilation centered at the origin with scale factor 2. The 6 pairs of distinct transformations from this list, how many commute? All right, so we have to convert these sentences to actual math or operations, and I'll explain. So the first one, if you have xy and it goes through that transformation, it would go to x plus 2 and then y. That's basically what that sentence means, translation 2 units to the right. The next one is not as straightforward. We have to think about it a little bit, and when we do, we find out that it's actually going to minus yx. That's what that means. A reflection about the x-axis, that basically means that the x value does not change, but we're going to the other side of the x-axis, so it would be minus y. And then finally, this one, a dilation centered at the origin with scale factor of 2, just means that you're going to 2x and 2y. Okay? And then I'm going to call this operation A, B, C, and D. Actually, what's the word they're using? Transformations. Okay, so transformation A, transformation B, C, and D. Okay, so then how many pairs would they be? Let me think about this. So we'd have A with B, A with C, A with D, or B with C, B with D, and then finally C with D. So there's 6 of these guys. And we have to figure out which one of these 6, as you can see, the answer choices are less than 6, so that makes sense. Which one of those 6 would satisfy the first part of that question, which is that when you did the first followed by the second, it would give the same result as the second followed by the first. So here we go. So what am I going to do here first? Let's just go through it in an order. So first I'm going to do this one here. So A to B, and then we're going to compare that with B to A. So if you first did A, it would be this guy. And then you take the result and do B. Hold on. Yeah. Then you do B. just getting a little confused here. So then that would mean, let me think about it. We're doing this guy up here. So it would be minus y x plus 2. Okay, so that is an A-B transformation. You did A and then you did B. A followed by B. Then B followed by A, that's you initially take your point and then you first do B. So that would basically make it minus yx. And then you take what you have and then do A on that. That would be minus y plus 2 and x. Okay, so then what you have to do is you have to compare the two final answers. Are they the same? If the answer is yes, that means they commute, which is the word they're using right here. If the answer is not the same, then they don't commute. So as you can see, these two guys do not commute. So do not commute. Okay, so this one, no good. Got it? So for the sake of time, I'll go through the ones that do commute. It's these ones and these ones. So here we go. So AC commutes with CA. And I'll show you how. AC would go from xy to x plus 2y. And then when you did A, and then you do C on this guy, and that would bring you to x plus 2 minus y. Okay? And then similarly, you do CA and see what happens. You first apply C, and that would be x minus y. And then you would then do the A transformation to this guy. And when you do, you would get x plus 2 minus y. And as you can see, that is the exact same as that. So these commute. You got it? So this one is a good. And I'll let you do these two. And you got to do some work, right? And when you do, you will find out that of those 6, only 3 commute. And therefore the answer is 3, and that would be C. One side of an equilateral triangle of height 24 lies on L. A circle of radius 12 is tangent to L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle is bounded by the triangle, the circle, and line, and can be written as a square root b minus c pi, where a, b, and c are positive integers, and b is not divisible by the square of any prime. What is a plus b plus c? Okay, so I've got to explain this as carefully as I can, so I will. So first, the challenge is figuring out, I'm going to put it on a coordinate axis. I don't think you necessarily need to, but I for some reason I always find it works for me. Okay, so first I have to draw that equilateral triangle, and that's that. And then I have to interpret what it is that they're asking here. Now, I believe the equilateral triangle that's fine. That looks pretty equilateral to me. But what is L? I think the L in this case is the x-axis that I drew. I think that's representing L. And then we have this circle. And, now I've got to figure out, where does the circle go? I think that is the interpretation of where that circle is. And I've got to make sure here that everything is properly drawn. Height 24, radius 12. Radius 12 means diameter of 24. So that means that those two guys, although it may not seem like that, they have to sort of, yeah, they've got to share sort of the same height. Yeah, I think that's the best as I can get to this diagram without repeatedly trying to make it perfect. Okay, so then what are we trying to get here? This region here, I'm hesitating to even, yeah, you see that tiny little red region? That is, I think, what we're trying to figure out the area of. The region that is defined as exterior to the triangle and the circle and is bounded by the triangle, circle, and line. Okay. All right. I wish it was a little bit bigger because it's so small that you may even get a little confused. But first what I'm going to do is I'm going to draw in a bunch of lines to help me. So here we go. Okay, let's go through this now. We're going to need a lot of 30, 60, 90 triangles. So I'm going to probably draw that stuff on the side. So the equilateral triangle, as you guys obviously know, has 60 degrees, right? And if you draw a line top to bottom like the height, they told me that the height is 24. Now this is 30 degrees. So we can use the famous ratio that the sides of a 30, 60, 90 triangle are of the ratio 2, 1, and root 3. That's the ratio of the sides. So if we want any of these sides, the actual length, we can use those ratios. So that means, for example, root 3 over 1 is the same as 24 over x, and therefore x would be 24 over root 3. 24 over root 3. And when you rationalize the denominator, you would get 8 root 3. So this is 8 root 3. And similarly, this would be 16 root 3, that side there. So there's a lot of that in this question. There's a lot of 30, 60, 90 triangles. But I want to do it on the side because otherwise the diagram will get a little bit too messed up. Now I'm going to call this B. This red area that we are interested, I'll call that A. And this sector I will call D. And then this whole thing I'll call C. Now if you're wondering what is C, it's everything else in that rectangle. You see that rectangle? I don't want to draw on it because it'll mess it up, and you'll understand what I mean. And when we take the full rectangle and say A would basically be equal to the full rectangle minus the B minus the C minus the D, and then we'll be able to figure it out. So here we go. Now, to figure out the rectangle, we obviously are going to need we have 24 as the height, but we're going to need obviously the width. So from here to here. Okay. Now, I don't know what it is, so for now I'm just going to call it x, and then later we'll try to figure it out. So the length of the area of the rectangle would be 24x, correct? And then the b, it looks like 1/2 base times height. So the base is going to be this guy here. Let me just from there to there, and that is the same as this, which is 8 root 3. So 8 root 3. And then the height is 24, so that takes care of B. C is two triangles, actually. Yeah, so it's 2 times 1/2 base times height. And because both of those triangles are similar, because see, this is a tangent point, so that's a right angle, and that's a tangent point, that's a right angle. So that's why they're both right triangles. Both have 1/2 base times height. The base for both of them would be 12, because it's just the radius of the circle. See, that's 12, and that's 12. And then the height would be x, correct? Yeah. And then finally, that sector, which is D, that's going to involve an angle. So let me put in that angle first, theta. It's going to be, well, first pi r squared, where the radius is 12, and then that theta over 360. And I'm pretty sure that is the way to do it. Yeah. And then, of course, A is, where is it in the question? Oh, here it is. That's what it's written as. So this is A, hold on here, A root B minus C pi. Okay, let me clean this all up here on the other side. So this looks like 24x minus 12 times 8, so 96 root 3. And then that's going to be minus 12x. And then this will be 144 over 360 pi theta. And you see, it does definitely look like that in terms of its, coefficients and all that. So I think we're on the right track. I think we can clean this up a little bit more. 12x minus 96 root 3 minus 2 over 5, I believe. 2 over 5? Yeah. And then pi theta. Okay, great. So that's a lot of progress there. Okay, but we, of course, now have to figure out what is x, because that is the missing piece of the puzzle here. X should be interesting. If you look at this, since those two triangles were similar, x is also the distance there, like the distance from this point here to this point right there. You see how that's x also, because since those two triangles are pretty much identical in terms of their lengths, the side lengths. So I'll draw that triangle actually on the side here. I'll draw it kind of like this. So this is x, and then we know that's 12 because that's the radius. And then we also know, what do we also know? Going back to the diagram, we know that this was 60 degrees. That was a right angle. That's 30 degrees. And therefore, these two angles, they're equal, and they have to add up to the remaining 60, so they would each be 30 degrees. Aha. Okay, so that means that's 30, and that's 60. So a little bit of angle chasing there. And therefore, since, as previously mentioned up there, the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3. That means x over 12 is the equivalent of root 3 over 1. And therefore, x equals 12 root 3. There we go. We got our x. Great. And this is 60 degrees. This is also 60 degrees. So then theta must be 60, since all those angles have to add up to 180. Okay, we got everything. So let's plug it back here and see what we get. So a root b minus c pi. So x, we are going to put 12 root 3. minus 96 root 3 minus 2 over 5 pi n 60 degrees, correct? Yeah. Okay, so this is 144 pi minus 96 pi, so that would be 144 minus 96, 48 pi. And this looks to me like 60 divided by 5 is 12, 12 times 2 is 24. And I believe we're done. So I wanted to take my time with this one, actually, because it's a very good question and it should be explained carefully. Okay, so now we can do the correlation. A is 48, B is 3, and C is, hold on here. Yeah, C is 24. So what do they want in the question? They want A plus B plus C, okay? A plus B plus C would therefore be 48 plus 3 plus 24, and that is 75. 75 is the answer, and that would be D. Let m be the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the units digit of m? M plus 1213 is a perfect square, so I'll just call it n squared. And m plus 3773 is also a perfect square, so we'll just call that k squared. And then if we subtract them, k squared minus n squared would be m plus 3773 minus m minus 1213. And k minus n, k plus n is the factorization there. And then the m's would cancel, interestingly. So that would be 2560. Okay, so, oh boy, so what do I, but m, we want it to be large as possible. So we want to maximize m. And to maximize m, we need to maximize either k or n, because they both, if you maximize m, you maximize n or k. So n and k, I guess. Okay, so, oh boy. Let's start with k. I'm just wondering which one should I start with. Does it even matter? But let's just start with k, since it's k minus n, k plus n. So what I have to do is I have to break up 2560 into possibilities. Well, there's one possibility, 2560, and I want to keep the numbers as large as possible. The next one is 1280. Yeah, and then there's many, many more. But we want to keep these numbers as large as possible in order to achieve that maximization. So let's start with the first one, when k minus n is 1 and k plus n is 2560. So 2k would be 2561. This is not going to work because it's not an integer. Because k squared has to be an integer. Yeah, because they're perfect squares. Okay, no problem. That one didn't work, so let's try that one. K minus n is 2. K plus n is 1280. And then 2k would therefore be 1282. And then k would be 641. Correct? And sub it back into here, I guess. And then n looks to me like 639. Right? Okay. And then I can figure out m. See, I can use either one of these. So for example, if m plus this guy right here, 1213 was n squared, and then n we know is 639, and then we can easily calculate the value of m. And when you do, you get m is equal to 407108. Now you can do the same kind of calculation with this guy if you preferred to use the K641, and you can do that on your own to see that you get the same answer for m. And what do they want here? The units digit of m. So the units digit is the last digit there, so that would be 8. 8 is the answer, and that's E. All of the rectangles in the figure below, which is drawn to scale, are similar to the enclosing rectangle. Each number represents the area of the rectangle. What is AB? All right, interesting question here. Okay, well, I'm going to do some labeling. The first, I'm going to just concentrate on this guy. Just call it width, W for width and L for length. And that rectangle that has an area of 32. And then the one right above it that has an area of 36, I'll call that width from there to there W2. And this length from here to here L2. And then we'll hopefully get some sort of a comparison, and we can work this out. Okay, when you add up all these numbers, the total area, and I'll let you guys do that, is 200. So if, okay, I'll label the entire top to bottom here X, and this entire length Y. So that means basically that XY is 200, since it's a rectangle. And what? And since they are similar, each of these rectangles, we can use the rectangle that has a area of 32 and compare its width and lengths. The width and length there would be the same as the width and length of the enclosing rectangle, the big one. And let's see what else. Oh yeah, you can also compare that to the areas, but the square root of it, because that's how it would work for area. So the area of I think this is correct, but if I'm comparing it to areas, it would be different. It would be, for example, the width of the small guy over the width of the big guy would be the same as the area of the small rectangle over the area of the big one, but the square root of that. That is correct. Yeah, I think this part is fine, but then when you compare the areas, you have to make it into this format. So that basically means that W over X, let's see here, is 2 over 5. So W is equal to 2 over 5 times X. Okay, and in a very similar way, I'll just keep it on the same screen here. L over Y is equal to 32 over 200, all under the square root sign. So L over Y would be equal to 2 over 5. So L would be equal to 2 over 5Y, like that. Got it? Okay, and then we can move right along here. In a very similar way, when we look at this, here we're looking at W and L, right? This guy. But now we're going to concentrate on that rectangle that I've labeled W2 and L2. In a very similar way, W2 over X is the same as 36 this time over 200, and the square root of that. And that is 6 over 10 root 2. And when you rationalize the denominator, you get 3 root 2 over 10. So that means W2 is equal to 3 root 2 over 10x. And very similarly, the L2 over Y has sort of a same pattern, 36 over 200. And that would be 3 root 2 over 10. And then same thing, it would be L2 is equal to 3 root 2 over 10 y. Got it? And we also know that this whole side from top to bottom, that we denoted as x, is equal to W plus L2, correct? So substitute it in. W is, where is it? W somewhere. Oh, here it is. It's 2 over 5x, and L2 is right here. So plus 3 root 2 over 10y. Okay, so that's good. And in a very similar way, I need some more space here. That was, yeah. So that basically means that x is equal to 2 over 5x plus 3 root 2 10 over 10y. So I can solve for x now. So this will be 3 over 5x is equal to 3 root 2 over 10 y. And then which one do I want to solve for? I want to get x in terms of y. So that means that x would be equal to 5 over 3 times 3 root 2 over 10y. So the 3's cancel, so you get root 2 over 2y. Correct? And then if I rationalize it, no, it's already rationalized. Yeah, because I don't need to rationalize the numerator. Okay, that's a very good finding here. It took a lot to get that, but we got it. And then we go back way to the beginning, right here, and utilize that fact, xy is 200. X times y is 200. And then substitute this very important finding, root 2 over 2y, and then y, and 200. Because what is our goal? It's to, what is the length of AB? So AB I have denoted as y. That's y. Okay, so this would be y squared is equal to 2 times 200 over root 2. So that's 400 over root 2. Let's rationalize the denominator. So 400 root 2 over 2, which is 200 root 2. And that's y squared. Correct? And then therefore y would be the square root of 200 root 2. Okay, let's see. Any of the answer choices? No, they're not. Okay, so what that basically means, I have to manipulate this. I have to modify it to somehow make it look like one of those guys. Okay, not a problem. Let me look at these first. We have 4 plus 4 root 5. Okay, there's no root 5. 10 root 2. Okay, that is not correct. It would be if that was 100, or even if it was 100, it wouldn't be correct. Anyhow, 5 plus 5 root 5, there's no root 5. 10, and what is that? The 8 to the quarter. The quarter, well, the exponent 1 over 4. Okay, and then 20. So I'm guessing it's D, but we got to make it look like D. It as the fourth root of 8. Okay, so how do I do that? If I break this up into 102, the 2 goes, if you go put the 2 inside the root, it would be 4 times 2, so root 8. Okay, I got it. And then therefore, that becomes 10, and you're taking the square root of a square root. So 1/2 times 1/2. Okay, that's how they got that 4 there. Okay, so a little bit of manipulation, and we get D. Two teams are in a best 2 out of 3 playoff. The teams will play at most 3 games, and the winner of the playoff is the first team to win 2 games. The first game is played on Team A's home field. The remaining games are played on Team B's home field. Team A has a 2/3 chance of winning at home, and its probability of winning when playing away from home is P. Outcomes of the games are independent. The probability that Team A wins the playoff is 1/2. Then P can be written in the form 1/2 m minus root n, where m and n are positive integers. What is m plus n? So we have 3 games, game 1, game 2, game 3, and then we have our home field, and we have the chance to win. And for Team A and team B, we'll have to calculate these numbers. So here we go. Let's fill out this table. So if the home field, well, let me go back and read the question. The first game is played on team A's, okay, and the remaining games are played on team B. Okay, so this is B and this is B. All right, so then now we can figure out these numbers here. Chance of winning for A on A's home field is 2/3. Chance of winning for B would actually be the complement, which is the other 1/3. For the home field B, the chance of winning for A is P, and therefore this would be 1 minus P. All right. Now, the probability that team A wins. Okay, so team A wins is our goal here. All right, well, team A wins in a few scenarios. The way this is structured is the first team to win 2 games. So you can either have a situation where team A wins the first 2 games, G1, G2, or it wins G1 and then G3, or it wins G2 and G3. So for each of these, there's going to be a probability, and then we add them up. Okay, G1, G2, if it wins G1, that's 2/3. And if it wins G2, that's P, probability. G1, G3, this one I have to be a little bit careful because G1 probability of winning is 2/3, but then it has to lose the second game. So you got to include that probability. That's probably a little tricky. And then G3 to win is P. G2, that means it lost the first game, correct? So that means 1/3. And then the second game it won, and the third game it won. Yeah, and that they're saying that whole thing is a half. Yeah, because see, they tell you that sentence there. So then we have to figure out P, and it's going to be in that form. Okay, I got it. All right. Took me a little bit of time to figure that out, actually, for some strange reason. All right, so let's, what do we want to do here? Let's multiply through by 3 to get rid of the fraction. So it'd be 2P plus 2P minus P squared plus P squared, and then this is 3/2 because we multiplied through by 3. And then this is going to be 2P plus 2P minus 2P squared plus P squared. And then that's going to be 4P minus P squared. And then finally, let's multiply through by 2 and put everything on one side. So it's going to be 2P squared minus 8P plus 3. Correct? All right. And then we will try to figure out the value for P. And I'm thinking we have to use a quadratic, which nobody likes, but that's okay. Let's see here. Minus 8 plus or minus the square root of minus 8 squared minus 4, 2 times 3, all over 2a. This, of course, should be in brackets if you want proper mathematics. Okay, so this is going to be 8 plus or minus, and what's that? 64 minus 24, so 40. And that's over 4, sorry. That's over 4. So this is going to be 8 plus or minus. Root 40 is what? 10 times 4, so 2 root 10? Yeah, 2 root 10. So that's going to be 2 plus or minus a half root 10. And we are told that it's of the form, this guy right here. 1/2 times m minus root n, okay? So 1/2 times m minus root n. And since the minus, we're going to choose the minus guy. And we have to put out a half, because we have to make it look like that. Okay, let's try to make it look like that. That means that would be 4 minus root 10. Yeah. So that means that m is 4 and n is 10. And they wanted me to find out m plus n, so that's going to be 4 plus 10, and that is 14. 14 is the answer. So that would be E. There are k positive integers where b is between 5 and 2024 inclusive, such that the base b integer 2024 is divisible by 16, where 16 is base 10. What is the sum of the digits k? A very quick primer here for those of you who are unfamiliar with bases other than 10. When I write a number like 45, it's always, this is base 10. But we don't actually even say that it's base 10. We just assume that it is. We don't even write this base 10, right? But what is 45? It's 45 times 10 to the power of 1. Sorry. It's 4 times 10 to the power of 1 plus 5 times 10 to the power of 0. I gotta learn base 10 myself, I guess. And that's how you get the 40 plus the 5, which is 45. Very similarly, if I gave you a larger number, say 3724, and I said, what is this in base 10? If you were to write it out. Well, okay, it's 3 times 10 to the power of 3 plus 7 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 4 times 10 to the power of 0, right? We're used to that, so we don't write base 10, and we certainly don't write the number like that. But base b, so for example, if I have 2024 to the base b, you can see there's a little b there that's microscopic, but you can see it. What does that mean? Well, it means the following. Base b would actually be the following. It would be 2 times b to the power of 3 plus 0 times b to the power of 2 plus 2 times b to the power of 1 plus 4 times b to the power of 0. You got it? So in this particular case, that simplifies to 2b cubed plus 2b plus 4. This is the value of this guy. And they're saying that this is divisible by 16. So for the sake of simplicity, if I divide through by 2, it'll be b to the power of 3 plus b plus 2. This guy would be divisible by 8. I think it'll make it a little bit easier to work with that. And then what they're saying is that for this range, for all the numbers that are between 5 and 2024 inclusive, for which values of b is this true? This. For which values of b is that true? So that's a lot of numbers. I mean, from 5 to 2024 inclusive, that's like 2020 numbers. And obviously, we're not going to go through every single one. So what I think you have to do in this question is you have to look for a pattern. And let's see. So let's start. Let's start with a value for b. Let's start with the value for this b to the power of 3 plus b plus 2. And then let's say, is it divisible by 8? Yes or no? Yeah. Let's say that. Let's make that table like that. And then hopefully we'll find a pattern sooner rather than later. And then we'll go from there. Okay, so we'll go 0, 1, 2, 3, 4. Does it say anything about positive, negatives? K, yeah, the positive integers. So, yeah, I got it. Okay, so 5, 6, 7. Let's just go up to 7. Let's see what happens, and then I'll continue after that. Let me just see first of all. Well, first of all, if we put the value for 0, we get that. Is this divisible by 8? No, of course it's not. 1, we get 4. That is no. 2, we get 12. Again, no. 3, we will get 32, and that is a yes. That is divisible by 8. 4, well, you can continue, but this is no and no. And then 6, I believe, is 224. That's a yes. And then 352, that's a yes. Now, what's interesting is that if we continued with this list, and I want to do it side by side here, because if I go next to a value for b of 8, the reason I put it side by side is because this b equals 8 is the same as 0 mod 3. And therefore, it would have the same result. Same thing as if b equals 9, this is the same as 1 mod 3. And therefore, it would have the same result. And if it's 10, it would be the same as 2 mod 3. You see what I'm saying? 11 would be the same as 3 mod 3. 12, 13, 14, and 15. 14 and 15 would be the same. Well, 14 would be the same as 6 mod 3. And 15 is the same as 7 mod 3. So therefore, the result, which is the all-important result, the divisibilities would be the same. So that means for every cycle of 8, you're going to actually get 3 guys that will satisfy our condition. So, for example, from 1 to 8, for values of b, you get 3. And those 3 in particular were b equals 3, b equals 6, and b equals 7 from the table. And then when you go to the next group of 8, oh, sorry. This was 0 to 7, right? Yeah, 0 to 7. This should have been 0 to 7. Sorry about that. And then the next one is 8 to 15. That would also give you another 3. And in particular, we had calculated that as 11, 14, and 15 from our list. This was 11, this 14, 15, and so on. You just kind of keep going like that. Dot, dot, dot. You keep going. And eventually you get to the last 3, because we're going all the way up to 2024. So you'd go all the way up to 2017 to 2024. Those final 8. 17, 18, 19, 20, 21, 22, 23, 24. And for those, there's going to be 3. And those ones, I can figure this out. It'll be, if you want the actual numbers, it'll be it will be 2019, 2022, and 2023. Yeah. So that means we have a bunch of groups of 3s. So how many groups are there? 2024 divided by 8, because each of these are groups of 8. So the total is 2024. So 2024, let me just do it on the side here, divided by 8. That's how many groups we have. So that's 253. So we have 253 groups of 8, and for each group we have 3 that would satisfy our equation. Yeah, so that's 759. That's how many values. But here's the thing, this is a tricky question, that b is for between 5 and 2024. So it's not between 0 and 2024. So some of these guys, well, not too many, just this guy is disqualified from being. So from this 759, we have to take away that guy. We have to take away 1. So that actually, yeah, let me write it here. Because b is between 5 and 2024, b equals 3 does not qualify. Does not qualify. Whatever you want to say. I mean, this is not a long answer question, and you just have to find the answer and circle it. But I'm just saying for the sake of completion. So this actually becomes 758, and this is what is represented by that k, this k here that they keep talking about. And then they want the sum of the digits of k. Okay, sum of the digits would be 7 plus 5 plus 8, and that's 20. So 20 is the answer to a pretty challenging question, actually. D. The first three terms of a geometric sequence are the integers a, 720, and b, where a is less than 720 is less than b. What is the sum of the digits of the least possible value of b? Okay, so geometric sequence, right? Okay, so geometric sequences are of the form a, ar squared, ar cubed, and so on. And the first term over the second term is equivalent to the third term over the second term, like that, and so on. And as you can see, all of these are basically just r. So we're going to use that. So our terms are a, 720, and b, correct? Okay, so that means that 720 over a is the same as b over 720. So that means 720 squared is ab. All right. And we need to, what do we need to do? Oh, the least possible value of b. Okay, so, and then we're given something. So this is an experimentation question. I don't think there's any formula here. So the first thing I have to do is break up this 720 into its prime factors. 720 itself in prime factors: 2 times 2 times 2 times 2 times 3 times 3 times 5, and then it's all squared. That means that AB, that's 2 to the power of 4, so if it's squared, it'd be 2 to the power of 8. That means 3 to the power of 2 squared, 4, and then 5 squared. Okay, so that's the grand factorization of that number. And we want b to be as the smallest possible, least possible value. Okay, so since b is greater than 720, let's see if we can get a number close to 720. And then eventually, what's the sum of the digits? They're being tricky here. They didn't actually give me the value of b, because if they did, then it would be much easier. Well, I mean, yeah, it would be much easier, but they didn't give me the value of b. They gave me some of the digits. Okay, so they made it hard. Okay, so, well, the first thing I thought is we just have to fiddle around with that. So b is obviously a component of that. Since a times b equals that, b is part of, that number. So how about if we just took out the 2 to the power of 8? I'm just experimenting here. That's 256. That can't be b, because b has to be greater than 720. But what if I multiplied that by just 1 3? Then that would be 256 times 3. And that would be 750 plus 18, so 768. That's fairly close to 720. So that's my candidate for the B, because I don't think you'll get any number that's less than 768 and greater than 720 if you're looking at this inequality. So if that's my candidate for B, what are the sum of the digits? 7 plus 6 plus 8, and that is 21. 21 is E. Let S be a subset of 1, 2, 3 until 2024, such that the following two conditions hold. If x and y are distinct elements of S, then absolute value of x minus y is greater than 2. If x and y are distinct odd elements of S, then the absolute value of x minus y is greater than 6. What is the maximum possible number of elements of S? So let's see what we can do here. Let's see. When we try to make a subset, let's first concentrate. Well, we actually have to abide by both rules, but let's just see what we can do. Start with 1. And then the absolute value of two elements has to be greater than 2. So I can't put 3 as my next number, because 3 minus 1 is 2. It's got to be greater than 2, according to that first condition. So I put 4. These two numbers so far, if they were distinct elements of S, they would satisfy that first condition, because 4 minus 1, or 1 minus 4, you're taking an absolute value, so it doesn't matter, is 3, and that is greater than 2. Okay, so far so good. The next one, let me go up by 3 again, because I have to in order to satisfy the first condition. And so far, so good. But here's the problem. Now, if you look at the second condition, if x and y are distinct odd elements, so the only odd elements so far are 1 and 7. Now, if I subtract them, take an absolute value, it equals 6. But it's got to be greater than 6. So that falls apart immediately. Okay, no problem. Go back to the drawing board. Let's try again. So far I was okay, but now let's choose an 8. Now I'm still fine. Next number is you've got to go up by at least 3 in order to satisfy this first condition here. And let's see, am I still okay? I'm still okay. Let's go up by 3 again. And I think I'm still okay. But if I go up by 3 again and put a 17, then that 17 and that 11, when you subtract them, will be 6. And that second condition would not hold true. So I've got to go up to 18. And then continuing like this, and for each number that you add, you check if the first condition is valid and the second condition is valid. And then you'll get a list like this: 21, 24, 28, 31, and so on, right? So what do we have here? We have a difference of 3, a difference of 4, a difference of 3, a difference of 3, a difference of 4, a difference of 3, a difference of 3, a difference of 4, a difference of 3. Okay, so I got it. It's a 3, 4, 3, 3, 4, 3, 3, 4, 3 pattern. Okay, so that means that 3 elements have a gap of 3, 4, and 3, so that's 10. So 3 elements would have a gap of 10. Okay, so but that's just one group of elements. Is there another way of doing this? So let's see. Well, we started with 1, and when we started with 1, this is the only way we could do it because this one fell apart. So let's start with 2. And similarly, we have to put 5, we have to put 8, we have to put 11. But then this 5 and the 11, that falls apart because 11 minus 5 is 6. So this one, no good. Okay, no problem. Just like as before, let's try again. We tried the 2, 5, 8, 12, and then 15. Because you got to go up by at least 3. So far, I think everything is okay. 18, 21, and then, of course, then that falls apart. So that's no good because 21 minus 15 is 6. It's got to be greater than 6. Okay, so that means that this, and you can keep experimenting with this, you'll see this kind of pattern will always fall apart. So that makes me think that I should probably change the second guy and then make that a 10 and then a 14 like that, like a 4-4-4 pattern. And this is after experimentation. So this is actually a very time-consuming question. And then this will work. This will work. But this is a 4-4-4 pattern. So that means that 3 elements here have a gap of 12. So which one of these do you think has more terms? Because that's what they're asking for in the question. Maximum possible number of elements. Well, I said terms, but same thing. Do you think this guy or this guy? Which one has the more terms? Well, it's going to be this one. Why? Because there's not that much gap. There's less gap between 3 elements. So there's going to be more terms, more elements in that set. Yeah, or subset. Yeah. Whereas this one, because they're a little bit more spread out, there's going to be less terms. So we got to go with this one here. Okay, so let's do that. And now what do we have to do? We have to count how many. Okay, and knowing that it goes up to 2024. Okay, that shouldn't be too much of a problem. Let's arrange it a little bit differently. 1, 4, 8, 11, 14, 18. If you arrange it side by side, it might be a little bit easier to count. 31, 34, 38, like that. And then kind of ... This will obviously keep on going for a long time. And then eventually you'll get to 2011, 2014. Because see, these are all going up by 1. Oh, well, they're going up by 10. The units digit is always 1. And then the other ones are very easy to figure out since you just follow that same 343 pattern like that. And then the very last one would be 2021 and then 2024 because it ends at 2024. So now we have to count these. This is 202. That's pretty easy to do. It's just multiples of 10. So, and then each one will have 202 columns, and each column has 3 numbers. And then at the very end, you've got these guys. There's 2 of those guys. So it would be this plus that. So that's 606 plus 2, which is 608. And 608 is the answer, which is C.